Take a good look at this photo, a blurry, orange ring in the dark with not a lot to see at first glance. But this is one of the most important images ever recorded, and for most of the last century, scientists were fairly sure a photo like it could never be taken. It's a photograph of a black hole. The thing sits 55 million light years away, in the middle of another galaxy, and it swallows light so completely that, by any normal logic, there should be nothing there for a camera to capture. No surface, no glow, no reflection. And yet in 2019, a team of scientists managed to photograph it, and the way they pulled it off is arguably the more interesting half of the story. It involved a telescope the size of the planet, half a ton of hard drives on airplanes, and a set of equations Einstein wrote before anyone had left the ground. Let's start with what you're actually looking at, because it's easy to misread. The black hole is the dark circle in the center. You're not really seeing the black hole itself though. You can't. It gives off no light. What you're seeing is the material around it, gas that has been heated to enormous temperatures as it spirals inward, glowing fiercely, its light bent into a ring by gravity strong enough to curve the path of light itself. That gas, by the way, isn't just warm. As it falls inward, it gets compressed and sped up until it reaches millions of degrees, hot enough to shine in radio waves and X-rays rather than ordinary light. It's some of the brightest material in the galaxy, which is part of why a black hole, the darkest thing imaginable, tends to be surrounded by a blaze of light. That contrast is exactly what made the photo possible in the first place. There's another detail worth pointing out. One side of that ring is noticeably brighter than the other, and that's not a flaw in the image. The gas on the brighter side is moving toward us at close to the speed of light, and motion at those speeds makes the light look stronger. So the lopsided glow is actually telling us which way the material is spinning. What you're watching, in effect, is matter circling a drain it can never climb back out of, and the shadow in the middle is the boundary. Cross it and nothing comes back. To put the difficulty in perspective, catching that ring from Earth was roughly like photographing a donut sitting on the surface of the moon. That's the scale of what they were trying to resolve. Now, where does this thing live? The galaxy is called Messier 87, and it's a giant sitting in the Virgo cluster 55 million light-years away. It makes the Milky Way look modest. Trillions of stars packed into a huge elliptical smear of light. Distances like this do something odd to the idea of now. The light leaving M87 at this moment won't reach Earth for another 55 million years, and the light in that famous photo left the galaxy around the time the dinosaurs were disappearing here at home. So we're not seeing Powehi as it is. We're seeing a very old picture that happened to take 55 million years to arrive, which is the only way anyone ever sees anything that far away. M87 isn't a typical galaxy either. It's one of the largest in our part of the universe, and big galaxies like that tend to have something substantial sitting at the center. That something is the black hole we photographed. Astronomers named it Powehi from a Hawaiian chant, a phrase that translates roughly as the adorned, fathomless dark creation. It's an old poetic name attached to a very modern image, and honestly a better fit than the catalog number it's usually filed under. The numbers behind it are hard to sit with. Powehi has a mass of about 6.5 billion suns, all of it compressed into a single point. It's one of the largest black holes we've ever found. Its shadow alone is wide enough to swallow our entire solar system, the sun, and every planet's orbit included, and it wouldn't be a tight fit. You could drop the whole neighborhood in, and it would barely register. It's worth remembering this isn't a star. There's no surface, no fire, nothing solid down there to crash into. Just a boundary and empty space, and past it, a drop with no floor. So how do you photograph something that's 55 million light years away, completely black and buried in the glare of an entire galaxy? The plain answer is that you can't, at least not with any single telescope ever built. It would be like trying to read a newspaper on the moon from your back garden. To resolve something that small and that far, you'd need a telescope roughly the width of the Earth, which is, in a sense, what they made, though not by building one enormous dish. Instead, they took 8 radio telescopes that already existed, scattered from Hawaii to Chile to the South Pole, and had all of them observe the same target on the same nights. On its own, each one is just a normal observatory. The trick is that radio telescopes can record not just the strength of an incoming signal, but its precise timing, and if you capture the same wavefront at 2 sites thousands of kilometers apart, the gap between them effectively acts like one gigantic mirror spanning that whole distance. Add in the Earth's rotation, which slowly sweeps the dishes through new positions over a night, and the array starts to behave like a single instrument, nearly the size of the planet. The project was called the Event Horizon Telescope. Getting it to work was its own ordeal. The timing between the sites had to be accurate to fractions of a second. Each telescope synced to an atomic clock. The weather had to cooperate at every location at once, on the same night. There were a lot of ways for the whole thing to fail, and not many for it to succeed. Then there was the data. The telescopes recorded around 5 petabytes of it, which is millions of gigabytes, far more than could be sent over any internet connection. So the team did the low-tech thing. They saved everything onto a small mountain of hard drives and physically shipped them to a central location to be combined. After that came 2 years of painstaking work by a team of more than 200 people, turning that raw mess of signals into a single image. When it finally came together on their screens, the striking thing was how closely it matched predictions Einstein had published in 1915, more than a century earlier. He'd worked out what the shadow of such an object should look like using nothing but math, long before anyone could go check. The prediction came first, by about 100 years. The confirmation showed up later, written in hot gas around a black hole in another galaxy. There's more to Powehi than the ring though. Shooting out of it is a jet of plasma thousands of light years long, larger than many entire galaxies. The way it forms is this: not all of the gas racing toward the black hole falls in. Some of it gets caught in the intense magnetic fields near the edge, flung around and blasted back out into space in a narrow beam moving at nearly light speed. The jet is so large and bright that astronomers actually spotted it back in 1918 through fairly ordinary telescopes without the faintest idea what they were looking at. For most of a century, people were staring directly at the exhaust of a supermassive black hole and filing it away as a curious little ray of light. Now, the part everyone wants to know about: what happens if you fall in? As you approach the event horizon, the difference in gravity between your feet and your head becomes so extreme that you get stretched into something long and thin. The technical term, and this is genuinely what physicists call it, is spaghettification. But the odd part isn't what happens to you. It's what someone watching from a safe distance would see. Because time slows down near a black hole, they'd never actually witness you cross the edge. Instead, you'd appear to slow, redden, and stall right at the boundary, growing dimmer and dimmer, seeming to hang there almost indefinitely until your light faded out. From your side, you'd cross over in an ordinary moment. From theirs, you'd never quite finish falling, and once you're past the edge, nothing gets back out. No light, no signal, no message of any kind. Whatever happens inside stays inside. It's the one place in the universe that keeps everything it takes. Powehi wasn't the end of the story. In 2022, 3 years later, the same team did something a bit more personal. They aimed their planet-sized telescope at the center of our own galaxy and photographed the black hole that lives there, the one called Sagittarius A star. It's a smaller object than Powehi, around 4 million suns rather than billions, and much closer, only 26,000 light-years away, which is a strange thing to sit with at the center of the galaxy you live in, the one that contains every person who has ever lived. There's a black hole, and everything around it slowly circles it. As of 2022, we've seen that one too. Which brings us back to that blurry orange ring, and a thought that's genuinely difficult to hold in your head. The dark center is a one-way boundary. Everything that has ever fallen into Powehi over billions of years, whole stars pulled apart, vast clouds of gas, possibly entire planets and whatever might have been living on them, is still in there, compressed into a point so small our mathematics stops being able to describe it, in a place where the ordinary rules of physics no longer apply. So this isn't only a photo of a black hole, it's a photo of the boundary itself, the place where space and time bend so severely that our best descriptions of reality start to break down. That faint smudged ring is about as close as anyone has come to photographing the point where physics runs out. It's worth remembering how far we've come with this. For most of history, black holes were just marks on paper, a prediction, a shadow buried in Einstein's equations that even he wasn't entirely convinced was real. Then, in 2019, we finally got a look at one directly, 55 million light-years away, an object the size of a solar system, photographed by a few hundred curious people, standing on a small blue planet. The universe is full of things we were told we'd never get to see. Powehi was the first of them to give in. It almost certainly won't be the last. Thanks for watching.